We're going to look some more today at equations with variables on both sides, and we're going to look some more at the special cases, when it's a no solution, when an equation has many solutions. There's going to be several on here you're going to look at and you're going to say, I can do this. If at any time you want to pause the video and you want to try to work the problems by yourself, feel free to do that. Just make sure you turn it back on and check it. There are a couple that have a new thing, something we didn't do yesterday that we're going to have to do today. But I think you can handle it. If you don't want to, just keep watching and keep copying, okay? All right, let's start with this little quick right here. It says, in your own words, describe what a solution to an equation is. So I want you to pause the video and I want you to write here in this space what you think a solution to an equation is. Okay, that's some pretty messy handwriting. I probably should not have put the little lines there because it's a little hard to write. But a solution to an equation is a number that makes the equation true. Now, you don't have to erase your answer, or you don't have to get rid of your answer, but make sure you have something down, if you haven't already, that it makes the equation true. When you plug the solution in, it gives you a true statement. Okay, so let's look at two equations with one solution. These are both like yesterday, so if you think you can handle these two right now, feel free to pause the video and try it. If not, I'll walk you through these two. Okay, remember, when we are looking at an equation with a variable on both sides, our first goal or our first step is to find that equal sign. So we're going to find that equal sign, we're going to draw our line. Then we're going to look at the left side. Is there any distributive property on the left? No. Any distributive property on the right? No. Any combining like terms on the left? No. Combining like terms on the right? No. Then the next thing we do is we move the smallest variable. So I have a 2x and a 7x. Which one of those is smaller? 2x. So how do I get rid of a positive 2x? We're going to subtract 2x from both sides. Make sure you're writing this x here. I saw a lot of you yesterday not writing the x. We're not subtracting 2, we're subtracting 2x. Okay, so 2x minus 2x, that becomes 0. It goes away. I'm going to bring down, notice there's a minus sign there, I'm going to bring down a negative 5 equals 7x minus 2x is 5x, and I'm going to bring down a 20. And I messed up somehow. That should be a 20. Okay? All right. This is now a two-step equation. I find my variable. My variable's right here, so I've got to get rid of this plus 20. I'm going to subtract 20 from both sides. Negative 5 minus 20 is negative 25. Equals 5x, plus 20 minus 20 is 0. That went away. I'm going to divide both sides by 5. That becomes 1. X equals negative 5. Now, why this is a solution is this number makes this equation true. If I plug in negative 5, 2 times negative 5 is negative 10. Negative 10 minus 5 is negative 15. If I plug in negative 5 over here, 7 times negative 5 is negative 35. Negative 35 plus 20 is negative 15. So negative 15 equals negative 15. This next one, 3m plus 12 equals 2 times the quantity m plus 2. Find your equal sign. Look on the left. Any distributive property? No. Look on the right. I do have distributive property, so I'm going to bring down this 3m plus 12. I'm going to do 2 times m is 2m. 2 times 2 is 4. Now, any combining like terms on the left? No. Combining like terms on the right? No. Check your variable. I've got a 3m and a 2m. Which one's smaller? The 2m. I'm going to subtract 2m from both sides. 3m minus 2m is just 1m. I don't have to write it. Plus 12 equals 4. This is just a one-step equation. I'm going to subtract 12 from both sides, and m is negative 8. Occasionally we get lucky and we get a one-step equation. This is a solution because if we were to take negative 8 and plug it in here where m is, this would be a true statement. Okay, now both of those equations before had one solution. They had one answer. They each had an answer that made that equation true. Now let's review what an equation with no solution looks like. This first one, 7n minus 3 equals 7n plus 6. I think you can handle this one. So why don't you pause the video, try this one on your own, see if you can get the fact that it has no solution. That one was too easy, wasn't it? We had 7n. We noticed those are the same. We subtract 7n from both sides. We're left with a negative 3 on the left. We're left with a 6 on the right. Negative 3 and 6 are not the same thing. Since we get something that's not true, that means there is not an answer. There is no value of n that would make this true. It doesn't matter what I plug in for n, this will never, ever, ever be true. So it is a no solution. Now the second one is similar, but there's something we didn't do yesterday that we're going to do in this problem. So why don't you watch along with me, okay? We look at the left, we look at the right. Is there distributive property on the left? There is. So we're going to do 2 times 4y is 8y. 2 times a what? Negative 5 is negative 10. Is there distributive property on the right? No. But what do you notice? Those are like terms, right? 3y and 5y, they're on the same side of the equal sign. We can combine them. So we're going to put the 3y and the 5y together. 3y plus 5y is 8y. Now notice the only reason we can do that is because our equal sign is not between those two. When they are on the same side that way, we're going to circle and combine. But if the equal sign's in the middle, we cannot circle and combine. Okay? Now, same thing we've been doing. I've got variable on both sides of the equal sign. 8y, 8y, they're the same thing. I'm going to subtract 8y from both sides. 8y minus 8y is 0. It goes away. Negative 10 equals 8y minus 8y. Now over here, there's nothing left, so I have to write that 0. Does negative 10 ever equal 0? No. When you get something that's not true, you write no solution. That means there is no value, there is no number we can plug in for y to make this true. Let's look again at equations with infinitely many solutions. Now, infinitely many is the fancy word for many solutions. Infinitely many means we can't count them. So you might see on a test, you might see somebody say infinitely many solutions. You might see many solutions. You might also see an infinite number of solutions. They'll talk about that several ways. So this first one on the left over here, 2x plus 6 equals 2 times the quantity x plus 3. I believe you can handle that one. Why don't you pause the video, try that one on your own, see if you get that this has many solutions. Does yours look like mine? I did distributive property. I should notice right here that both my sides match. When I get rid of that variable, I end up with 6 equals 6. How often does 6 equal 6? Always. That means there are many solutions. That means it does not matter what I plug in for x. It is going to make this equation true. You can pick any number you want, and they all work. So this has many solutions. Now this next one's just a little bit different. It's got one step we have not seen so far with this. We've done it with multi-step equations, but not with variable on both sides. So find that equal sign so that you split up your left and your right. Look on the left. I have distributive property. So I'm going to do 2 times W is 2W, 2 times 3 is 6. No problem. Now, over here, I also have, on the right, I've got distributive property right here. So 2 times W, don't forget your equal sign, is 2W. 2 times 1 is 2. Then I've got this plus 4 out here. So what do we do after we look at both sides for distributive property? We have to look at both sides for combining like terms. Do I have anything I can combine on the left? No, those are not like terms. What about the right? See your two numbers here? Those are like terms. I can combine those. So I'm just going to copy the left. I'm going to bring down the 2W. Then I've got plus 2 and plus 4. Notice the equal sign is not between them, so I can combine them, and I get plus 6. Now, this should look familiar. You've been given what you were given just a few minutes ago, but let's finish it out. Let's subtract 2W from both sides. I get 6 equals 6. That means this has many solutions. Doesn't matter what you pick for W, it's going to work. You might also see, here's a word I'm just going to introduce, you might see this called an identity. When you get something that is always true, it is often called an identity, mostly because something is equal to itself. When something is equal to itself, that is an identity. Okay, you are ready to do some practice.